Hello students, welcome to YouTube channel Vidya for Success. Dear students, in this video, let us study the concept of Ogives. Ogives are also referred as cumulative frequency curves. So what do you mean by cumulative frequency curve, or what is the use of an ogive? Let us say in a class there are 60 students. So each 60 students, each one of them, they have considered or an examination. Okay, they have taken up an examination for 100 marks, let us say. So out of 100 marks, some of them have scored below 20, some of them have scored below 30 marks. So there is a wide distribution of marks from 0 to 100. But we are interested to know how many of them have scored less than 50 marks. For example, how many of them have scored more than 85 marks, or else how many of them have scored less than 35 marks. So in case if I have to say precisely what is the frequency below a particular value or else above a particular value, then I need to consider ogives or cumulative frequencies. Okay, so the curve drawn against the cumulative frequencies are referred as cumulative frequency curve. So in this complete video, we will be studying how to construct these ogives. Okay, so here I have considered a representative diagram. So the representative diagram is showing both the less than ogive and more than ogive. Okay, and using the ogives we can also find the median. All these things will be discussed in this video. So first of all, what do you mean by an ogive? So the curve drawn for cumulative frequencies against the class limits are called cumulative frequency curves or ogives. So what is an ogive? So ogive is nothing but the curves drawn for cumulative frequencies, not for frequencies. So for a problem, if they have given us frequencies, we need to find cumulative frequencies. So there are two, as we know, there are two types of cumulative frequency. One is less than, another one is more than cumulative frequency. So in case if they ask us to find both less than ogive and more than ogive, then we have to construct first of all both less than cumulative frequency and more than cumulative frequencies. And later against the class limits, we will be plotting these cumulative frequencies so that we can get the ogive or cumulative frequency curves. So on a whole, what do you mean by an ogive? The curves for cumulative frequencies, the curves drawn for the cumulative frequencies against the class limits. So as we know, for a class there are two limits, lower limit and upper limit. For the less than cumulative frequency, we will be considering the upper limit. For more than cumulative frequency, we will be considering the lower limit of the class. So here the curves are drawn for the cumulative frequency against a particular class limit, either less than or more than class. Less than lower limit or more than upper limit. So any one limit we will be considering. So the curve which has been obtained after doing such a procedure or process is referred as cumulative frequency curves or ogives. There are two types of ogives, less than ogive and more than ogive. So what is less than ogive? So here we will be drawing a curve for the cumulative frequency against the upper class limits. Okay, so please notice here I am having a table showing the marks obtained and number of students. So this is the frequency, but I cannot construct ogives using frequency. I need cumulative frequencies. So this is less than cumulative frequency. 5 plus 3 is 8, 8 plus 4 is 12, 12 plus 3 is 15. So this is how I have constructed less than cumulative frequencies. So now what I have to construct? Now I have to construct less than ogive. So how to do that? How to construct less than ogive? Very simple. The upper class limits are taken along the x-axis. So in the class interval there are two limits, lower limit and upper limit. So for less than ogive we will consider only upper limits. Upper limits are considered for the x-axis and cumulative frequencies they are considered for the y-axis. So here the diagram is just a representative diagram. It is not indicating, or it is not the diagram drawn for this table. Okay, this is some completely different, two different representative diagrams. So, but here how you are going to construct less than or give? The upper class limits are taken along the x-axis and the corresponding less than cumulative frequencies are taken along the y-axis with appropriate scale. Then later, the plotted points on the graph are joined by a smooth curve. For example, let us say for the upper limit here 10, uh, under the x-axis 10, we'll be noticing what is the less than cumulative frequency 5. For example, 5 somewhere here. I'll be making one plot, one marking here. Next, for 20, somewhere here 8. Similarly, for 30, 12. Okay, so after plotting the points, they need to be joined by a smooth curve, not by straight lines. So the plotted points on the graph are joined by a smooth curve. The curve obtained is less than or give. Okay, so very simple. So what is a less than or give? So the upper class limits are taken along the x-axis and the corresponding less than cumulative frequencies along the y-axis with appropriate scale. Later, the plotted points are joined by a smooth curve. The curve which we obtained by joining these plotted points is referred as less than or give. That's all. Next, more than or give. That's a complete reciprocal of less than or give. So here in more than or give, we will be considering the lower class limits. That's very important. So lower class limits will be considered along the x-axis and the corresponding more than cumulative frequencies along the y-axis, not less than. Please notice here. So these two are very important. So in the class interval, what we are considering? Only the lower class limits. In the frequencies, which particular frequency we are considering? We are considering the more than cumulative frequencies. Okay, so the lower limits of the class are considered along the x-axis and the more than cumulative frequencies along the y-axis with appropriate scale. The plotted points on the graph are joined by a smooth curve. Once again, as we have followed in the less than cumulative or give, it's the same procedure here also. All the plotted points need to be joined by a smooth curve. The curve obtained is nothing but the more than or give. Okay, for example, here the 0, 10, 20, 30, these are all the lower limits. So the more than cumulative frequencies will be plotted against these lower limits. Okay, so here I have not considered more than, these are less than cumulative frequencies, but actually I need to go with more than cumulative frequencies. So if it is the case, then I'll need to go with, first there will be 53 minus 5 is nothing but 48. Similarly 48 minus 3 is 45. So you'll be getting more than cumulative frequency. So more than cumulative frequencies will be plotted against the lower limit of the class. So we'll be getting a curve of this nature. This is the more than cumulative curve, or else more than or give. Next, more than or give can be used for what? In case if I want to precisely say what is the number of frequency above a particular given variable value, then I can make use of more than or gives. Or else if I want to precisely pinpoint what is the value for a particular variable for the given frequency, then also I can make use of more than Ogive. Okay, so these are the details with respect to less than Ogive and more than Ogive. The next topic is quartiles. So using the Ogives, we can also identify the quartiles. What do you mean by quartile? The entire frequency distribution can be divided into 4 equal parts. Okay, so in order to divide the entire distribution into 4 equal parts, we'll be considering 3 quartiles: quartile 1, quartile 2, and quartile 3. So that's why to locate the quartiles, that is nothing but which particular quartile, whether first quartile or second or third, we will be considering the formula I into n by 4. What is I here? I will indicate which particular quartile. I can take value 1, that is nothing but first quartile. If it takes value 2, it is second quartile. If it takes value 3, it is third quartile. So entire area will be divided into 4 equal parts using 3 quartiles. So here, in case if I want to find the first quartile, so how to do that? Here I will be 1 into n. What is capital N? Capital is total frequency. Okay, let us say total frequency is, let us say 100. So 1 into 100 divided by 4, nothing but, let us say the value is 25. So 25th value, so the 25th, here I need to look out for the 25th value in the y-axis. Okay, so let us say that somewhere here is a 25th value. Okay, I am taking an imaginary value, it's not an exact value. 25th, okay, this is an exact value. Here, 25 value, it falls here. So here, from here we will be drawing a line parallel to the x-axis. Here this is the x-axis, we will be drawing a line parallel to x-axis until it reaches the less than Ogive. Okay, so when the point reaches less than Ogive, from this particular point we will be drawing a line perpendicular to x-axis. So how we are going to find the quartile? For example, if I am finding first quartile, first I need to know what is I into n, capital N by 4th value. From this particular value, we will be drawing a parallel line to the less than Ogive. So from there, the point which touches the less than Ogive, from there we will be drawing a perpendicular line touching the x-axis. So the point where it touches the x-axis, that is the quartile value, ith quartile value. For example, this is the first quartile value. Similarly, if I want to know what is the second quartile, then 2 into capital N by 4th value. From here I'll be drawing a parallel line, and from this particular point where it touches the less than Ogive, I'll be drawing a perpendicular line towards x-axis, and this particular place or point on the x-axis is the second quartile, nothing but median. Okay, the next one is the third quartile, that is upper quartile, usually referred as upper quartile. So first quartile, second quartile, and upper quartile. So using less than Ogive, we can easily plot quartiles. Okay, but not using more than Ogive, only using less than Ogive, we can plot the quartiles. Similarly, we can also find median. So how to find median? So what is median? Median is nothing but the it is a what to say, it's a vary value which is going to say what is the average value. Okay, so median will let us know what is the average. Median is nothing but the middlemost value we usually will be saying. Okay, median is the middlemost value. So in case using Ogives, this is less than Ogive and this is more than Ogive. If you want to plot the median value, yes, you can do that. How to plot the median value? So let us say this is the less than Ogive and this is the more than Ogive. So the point where both the Ogives meet, the intersection point, from there we will be drawing a perpendicular line towards x-axis. The point where it meets the x-axis, this particular point, the value here, it is the median value. Okay. So how to find the median? Usually both less than Ogive and more than Ogive will be considering a common axis, nothing but both lower limit as well as upper limit, both of them are considered in the same x-axis, but cumulative frequencies are considered in the y-axis, isn't it? So from the point of intersection of both less than Ogive and more than Ogive, we will be drawing a line perpendicular to the x-axis, and the point that which meets the x-axis, where it meets the x-axis, that is the value of the median. So Using Ogive, we can find out following values. First of all, we can, using less than Ogive, we can say what is the number of frequency below a particular value. Similarly, using more than Ogive, we can say what is the number of frequency above a particular value. Using Ogive, less than Ogive especially, we can find the quartiles, Q1 first quartile, Q2 second quartile, and Q3 third quartile. Similarly, using Ogives, we can also find the median. So with this, I'm going to end the session. Thank you.